Hello, I'm Jerry Winslet along with Kenneth Ezell, and in this course we're going to be talking about troubleshooting standard electric water heaters. Standard residential electric water heaters typically use two 4,500 watt heating elements, an upper and a lower, to heat water stored in an insulated tank. Because of home wiring limitations, usually only one element is on at a time. This is referred to as non-simultaneous operation. When a heater is first installed, the upper thermostat will turn on the upper heating element to heat the top third of the tank first. When the upper third of the tank reaches the set temperature, the upper element turns off and the lower thermostat will turn on the lower heating element to heat the remaining 2/3 of the tank. Because of how a standard electric water heater works, if the tank isn't full of water when the unit's first turned on, the upper element will dry fire and burn out. During day-to-day use, cold water enters the top of the tank through a dip tube, which forces the cold water to the bottom while pushing hot water out of the connection on top. The lower thermostat detects the cold water and turns on the lower heating element. Since only a portion of the tank of hot water gets used at any one time, and the top of the tank rarely gets cold, the bottom heating element does the majority of the work over the heater's life. All right, so now that we know the features and benefits of a standard electric water heater and we know how they work, let's talk about troubleshooting. And really it boils down to two different scenarios. We've got call centers here, we know what's going on in the field, and really the top two service calls we get for standard electric water heaters is no hot water and not enough hot water. And we've got PDFs that you can download and kind of follow along as we go through the troubleshooting steps. So we're really talking about no hot water and not enough hot water, and really no hot water is the most common, isn't it?
Yeah, no hot water is going to be the most common call. I mean, people aren't usually going to tell you that the water heater is working great.
Yeah.
Some people may, but not usually.
Yeah.
Right? So really no hot water can be broken down into two separate calls.
Okay.
If it's a new installation, there's a few things I want to check for.
Okay.
Or if it's a water heater that's been installed previously and it's been running fine for years, that's going to kind of change what I'm looking for.
Okay.
Right? But one of the first things I want to check when someone says they have no hot water is to make sure they actually have no hot water.
Okay, let's start with, let's say it is a new installation. So the first thing we're going to check is no hot water. What would I actually do? Do I go to faucets or?
Yeah, I want to check and make sure I actually have no hot water.
Okay.
And so one of the easiest ways to do that is to go to the relief valve of the water heater and touch it.
Okay.
If it's cold, that means the water heater's not working.
Right.
If I usually go to it and I touch it and it's hot, that means the water heater's working and you probably have an issue in your plumbing system like a failed mixing valve or something along that nature.
Okay, so let's determine that we don't have any hot water. We've been to all the faucets, we've touched the relief valve, everything's cold. What do I need to do first?
Well, on a new installation, what I'd usually check first is power.
Okay.
Right, and so I want to check power. I'm going to need a screwdriver. Right, and it's going to be pretty easy. Now, what I would recommend when doing this is go ahead and turning the breaker off.
Okay.
Right, if it's on, turn it off. I want to remove the access panel from the front.
Okay. So we're going to kill power to the water heater.
Yeah, go ahead and kill it. It's just easier to kill it while you're removing everything
Okay.
because the thing is, I want to have my hands in here, right? And I don't want to reach my hand in here with 240 volts going on because I'm actually going to have to pull off a protective cover.
Okay.
And so take the thing off, remove this plastic protective cover,
Okay.
turn my multimeter to volts, and what we're going to check for is AC volts. And we know this is, most of our heaters are 240 volt, 4,500 watt.
Right.
Right, and so I should have 240 volts between the top two screws of the upper thermostat.
Okay.
Right? So I'm going to stick one lead to each screw. Right now, I want to do this with power on. Of course, we don't have power on to this water heater.
Okay.
So once you remove all that, you want power on, touch the leads to the top two screws of the upper thermostat. You should have power.
Okay.
If you don't have power, that typically means either your connection up here in the junction box, something has gone wrong up here, or there's something going on through electrical service.
Okay, so let's say we do have power and we still have no hot water.
If we do have power, then in this case, we know the water heater is getting electricity, so that should be good. Next place, I'm going to do the same thing. I want to check for power, usually at my upper heating element. So My upper heating element has 2 screws. I'm going to check between them for power. If I have power to the upper element and I don't have any hot water, that typically tells me there's something going on with the upper heating element.
Okay.
So on a new installation, one of the things I want to be curious about is how they actually purged air from the water heater.
Ah, okay.
Because all my power's there, right? I have power to the water heater, power to the upper element. We all know the upper element comes on first.
Right.
And so it should be getting hot.
Okay.
And if it's not getting hot, it's either because of one or two things. Either A, the element was exposed to air, and we've now burnt out the upper element by dry firing it.
Okay.
Or 2, we have a leak somewhere in the plumbing system. And one's way more common than the other.
Okay.
Right? So in a new installation, it's very important when we fill this water heater,
Okay.
right, that we open a water faucet, purge all the air out. Right, so
Okay.
typically what I recommend is opening a faucet, allowing the water to run out. And you're going to hear spitting and sputtering at first.
Right.
But when I get a pretty steady stream of water coming out, I want to allow that water faucet to run for at least 3 full minutes, right, until all the spitting and sputtering is stopped.
Now, is it good to do, multiple faucets, or does it matter?
Correct. You can open multiple faucets if you'd like, but at least as long as one's open,
Right.
it should be purged out. So
Okay.
it's just whatever's convenient to you. I personally am probably going to open multiple faucets. But
So based on that, based on a new installation, most likely the scenario is going to be you dry fired the upper heating element
Correct.
if you have no hot water.
correct, because it's going to be unlikely to have a plumbing leak on a new installation. I mean, you're going to have someone there, actually working on the plumbing of the home. They're going to figure out if something's
Right.
wrong with it like that.
Right.
Most common new installation, no hot water, is power or dry fired upper element.
Now, when we're installing an electric water heater, is it best for me to hook all my plumbing lines up first before I even go to my, and fill the water heater up with water before I even connect my electricity?
Correct. Electrical power is going to be one of the last things I hook up because what I'd like to do is hook all my plumbing up, get all that done,
Right.
turn the water on, fill the water heater up, allow it to pressurize, check for leaks,
Right.
right? And make sure all that stuff's good before I ever hook electrical power to it.
And that means open up all the faucets, get all the air out, do all of that before we even attempt to even remove this cover up here.
Correct.
All right.
And now you can actually check. I'm just going by, if I have voltage to the element, right, and it's not heating, the element's bad. Now you can actually check the upper heating element. You can ohm the upper heating element out and see if it's good or bad.
Okay.
Right, and what you'd want to do in that case is turn your power back off, remove both wires from the heating element, set your multimeter to ohms, which is an upside down horseshoe, test between the screws, and I should get around 12 to 13 ohms.
Okay.
So 240 volt, 4,500 watt element should read about 12.8, 13 ohms, somewhere right around in there, and that's an approximation, but it should be pretty close.
Okay, so that's on a new installation with no hot water. It's typically going to more than likely be a dry-fired upper heating element, and these are just some tests that you can do to double check, and because based on the calls that we get, we have an understanding that we know if you have no hot water, you just installed it, and you never got any hot water, then more than likely you've dry-fired your upper heating element.
Correct. And through that electrical checking, if you figure out you have power and you have the right amount of ohms
Right.
on the element, you do have a plumbing leak.
Right.
You either haven't waited long enough, it usually takes an hour or so or a couple hours for
Right.
the water heater to get hot. So if you've waited that long and you don't have hot water, you have 240 volts to the element, you have 12.8 ohms of resistance on the element, no hot water, it's a leak.
All right, so that's no hot water on an installation. Let's talk about on one that has been in for a while. So obviously when we have no hot water, we're going to do the same steps. We're going to check to make sure we have no hot water in the entire house. We're going to check the heater, and we've already done that. We've made sure the heater's cold and we have no hot water. What's my first step on one that's been in there for a while?
One of the first things I want to check would be the breaker box.
Okay.
Right, I want to go to my fuse panel and see if the breaker is tripped to the water heater. Now, if the breaker's on, I want to go ahead and turn it off.
Okay.
If the breaker's off, that's pretty much guaranteeing that I either have a shorted or grounded element. So
Okay.
I have to check that, and we're going to talk about that.
Okay.
So let's say the breaker's on because that's the most common. Go ahead and turn it off. The
All right.
reason why I want to turn it off is because, again, I'm moving this access panel. I got to raise all this stuff up and kind of look and see what's going on in here.
Okay.
And what I don't never want to stick my hand in here with power on.
Okay.
Power on is on the leads of a test instrument.
Okay.
But once I've removed the breaker, or turn the breaker off, remove the access panel, what I'm going to do is using my finger, I'm going to reach in here and push the red reset button.
Okay.
And what I'm looking for is just to really see if it clicks.
Okay.
You should be able to hear it.
All right.
You know, if it's tripped, you'll hear an audible click.
Okay.
Now, if it clicks, that typically means one of two things. Either have a grounded heating element, which could either be the upper or lower, you know, 2-element heater, or I'm going to have a bad thermostat, one or the other.
Okay, so let's say it does click, because it is the most common. We pushed it, it does click. You're saying we have a grounded heating element more than likely, or a stuck thermostat.
Correct.
Based on how this water heater works, it would it be more likely for me to go to the lower heating element, because that does all the work, really?
Usually so. We know by watching the video of how an electric water heater works. The upper part of the tank only heats about 1/3 of the tank.
Right.
The bottom heats 2/3.
Right.
Right? Anytime hot water is drawn, the bottom's kicking on. And so that means the bottom's really doing most of the work.
Okay.
Right? So if a part's going to fail, it's typically going to be the part that's the workhorse.
Okay.
And so what I want to do is usually check the lower element to see if it's become grounded. I'd want to check the upper one too.
Okay.
Right, to rule them both out. And if neither element's grounded, it's typically going to be an issue with the stuck thermostat.
Okay.
So to check for a grounded element,
Yeah.
I can show you right up here.
Yeah, let's
on
go
the
ahead and
upper
show us how we would do this. Now, typically, again, like you said, this would be performed on the lower heating element first, because of based on how we know this works. But you might want to do both.
Correct.
Okay.
So what I'm going to do is, you know, with power off, I'm going to remove that wires from the actual heating element, because I want to isolate the circuit. I want the element to be isolated.
Now, this is step number 3 on your PDF, if you're following along.
Easiest thing is set my multimeter to continuity,
Okay.
which continuity is going to tell us if we have a circuit,
Okay.
right? It's going to give me an audible beep. And I'm just going to touch one lead to each screw, right, and the other lead to the tank.
So what we're looking for is a circuit to ground, right?
Correct,
Yeah, to
'cause-
the tank.
Because the tank's grounded.
Okay.
And I want to check each screw to that ground. Now, if my meter beeps, that's going to tell me that the element's grounded and that element needs to be replaced.
Okay.
So like I said, don't forget you want to check both. You want to check
Right.
upper and lower. If either element's grounded, we need to replace it.
Okay.
If we check the element and it's not grounded, then that typically means it's going to be a thermostat. And just knowing how the parts work, if a thermostat's going to fail, it's usually going to be the lower one.
Lower thermostat.
Because it's doing all the work.
Okay. So this is if we have no hot water. We turn the power off. We press the reset button. It does click. Then we would check for a grounded heating element or a stuck thermostat in that case. But let's say we have no hot water, turn the power off, push the button, and it doesn't click.
Usually if we've turned the power off, pressed the button, it didn't click, about the most common thing would be in that case, as long as the breaker wasn't tripped or anything, it's just going to be a burnt out element, typically the upper element.
Okay, so it'd more than likely be an element.
Yeah.
And you would see that in a situation if it was, like I said, a new installation in that case. I mean, probably wouldn't trip the ECO, the
Correct.
cutoff, and you would have a burnt out upper heating element.
Yeah, the ECO only trips when the water gets too hot.
Right.
Right, and so the two things that causes the water to get too hot, one is a thermostat sticking, you know, meaning once it reaches the set point, it can't kick off. The actual contacts in it are stuck. The other thing would be the element, one of the elements being grounded, and what that means is that the filament wire is actually creating a circuit with the tank. Sediment has built up on the element, it's caused the element to fail in such a way to where you're creating a circuit, which means that element's going to heat, you know, at a very low power, because they always have power going.
Yeah, because
to
you'll get like, what, 110 volts to the one
Yeah.
side of the element.
Yeah, you always have power going to both elements. They only work when they have full power coming to it. So since they always have power, if any part of that filament wire was somehow ground out or come in contact with the tank, it's going to cause that little piece of element to heat under no control of the thermostat,
Okay.
which means the water is going to get super hot. Now, typically the difference is if the thermostat sticks, it's going to overheat very quickly.
Okay.
If the element grounds, it's probably going to overheat really slowly. You may not even
Right.
notice it unless you go out of town or away for a long time.
Okay.
You know, because just how long it would take for it to overheat with a grounded element. But either one,
Okay.
grounded element, stuck thermostat can cause the
ECO to trip.
ECO to trip. Another thing a grounded or shorted element can cause is a tripped breaker.
Okay.
So if you go to that breaker and it was off and you turn it on and it immediately trips again, do the same thing. Check for a grounded element. Chances are it just fell to where it's a dead short, causing a breaker to trip.
And then step number 5, it's pretty self-explanatory. That's if you've checked everything and everything checks out on the water heater, and you still have no hot water, you're going to need to look for a plumbing leak, right?
Correct. If like I said, if everything checks good, no hot water either way. You know, your elements have the proper amount of resistance. They're not grounded. The reset button's not tripped. The breaker's not tripped. If all that stuff's working and you have no hot water, you have a plumbing leak.
Yeah, and that can mean that more water's coming out than this thing can recover, and that's why you're not seeing it. So all that hot water is somewhere else, and this tank can never recover because you've got a plumbing leak on the hot water side.
Correct. And the easiest way to check for a plumbing leak would be just to go to wherever your water meter is. Make sure no one inside's using water.
Right.
Go to the water meter, see if it's spinning. If it's spinning, you have a leak.
You have a leak. All right, so that's no hot water. You can follow or download this PDF, use this, take it with you, keep it on your truck, and use this whenever you go to an electric water heater. It'll kind of help you out, keep you on track. All right, the second call we get from time to time, and this is our second most common call we get with electric water heaters, is not enough hot water. And this really, you've got to troubleshoot the call or the actual caller before you even get to the water heater, because what do they mean? Not enough hot water, doesn't last long enough, it's not hot enough? I mean, that's kind of vague, isn't it?
Yeah, it could mean several different things when someone says not enough hot water, right? And like you said, it could be one, just the temperature's not hot enough.
Exactly.
One of the more common things people forget about is that I had an old water heater. At some point in time, I may have turned up the temperature because my dishwasher required it, or my laundry wasn't coming clean enough, or something like that, right? They just wanted more hot water. They had a baby, needed more hot water because using more water. They've increased the temperature, right? Well, that water heater is now failed. When I go to put in a new water heater, these are factory set to 120 degrees.
Exactly.
Most of your older dishwashers want at least 140. Right? And so the big difference is, you know, most installers aren't going to remove the access panels and just the thermostat sub. So it could be nothing more than just temperature settings.
Yeah, just turn up your temperature, whatever it was before. But if we turn up the temperature, we have to do something. We have to install something else, right?
Yeah, anytime the temperature is set above 120 degrees, I'm going to recommend thermostat mixing valves at each point of use. And what that's doing, it's going to reduce the likelihood that you ever scald yourself.
Right.
Right? That means I can have the heater pretty much as hot as I ever want it, but it's going to ensure that, you know, normal temperature water, 120 degree water, is coming from my faucet.
Now that's going to actually help us out if we do install point-of-use thermostatic mixing valves, because that's going to make this water heater feel even bigger than what it is, right?
Correct. Anytime you increase the temperature of the water heater, you're going to have to mix in more cold water when you use it.
Yeah.
That way you don't burn your skin, which means you're drawing less water off the tank, which is going to make that water draw, you know, be longer.
Yeah.
Right? You know, you're going to get more hot water. You'll be able to take a little bit longer shower, be able to, you know, do more dishes before you take a shower, or do a load of laundry before you use a lot of hot water taking a shower.
Yeah, and I mean, really, at this time of year, and well, certain times of years, whenever it's getting colder and the groundwater temperature is getting colder, we might get more calls for not enough hot water. And installing a thermostatic mixing valve is actually going to help solve some of those issues.
Correct. Correct. So it'll make it last longer,
Yeah.
and that's one of the best things you can do.
All right, and now step number 3. Now, if we've ruled out it's not, you know, user thinking it's not hot enough or not getting a long enough shower, something like that, and it's not the tank temperature, that it may be an actual water heater problem. What kind of steps can we take to figure out not enough hot water?
Well, the biggest difference between, say, step 1 on the PDF and step 3, right?
Yeah.
Step 1 means you're going to get a good amount of hot water. It's just simply not hot enough. The actual temperature just doesn't feel hot enough, or you maybe run out a little quickly.
Right.
Step 3, technically, if you're having this issue, that usually means the lower element is failed.
Right.
Which typically means only a third of the tank is being hot, which is only going to last a couple of minutes.
Okay.
Right? And so if you're only getting a couple of minutes of hot water, then it's running cold, that typically means the lower element has failed. Just like we previously talked about, the lower part of the tank's the workhorse. If a part's going to fail, it's going to be probably either the lower thermostat becoming stuck or lower element opening, right? If the lower element opens, means it goes bad. It's just not going to heat water.
Right.
It's like a light bulb. You turn on the switch, it blows out, you have no light. Elements are very similar to that. You know, it's very rare that element actually ever grounds. It's more common that when it goes bad, it just opens, making you not have enough hot water.
Okay. All right, so that's not enough hot water. That's actually both of them right there. So there's our two top common calls when it comes to standard electric water heaters. Anything else you want to add about electric water heaters before we...
They're pretty simple. It's the most simple product we build. I would recommend the PDFs if you're going to work on these. It's just good information to have with you, and it's going to make your job easy.
Yeah, remember, download the PDFs, keep them with you, and remember, whenever you are installing these water heaters, always fill the tank up first before you hook up your plumbing lines. Fill the tank up before you even touch the electricity part on this, and you should be good. Download these PDFs, and I'm sure they're going to help you with troubleshooting electric water heaters.